Now in this part, we will study about the different problems which you might come across in competitive exams. For that, there is a sample of 5 questions which came across in the competitive exams. So in this particular video, these are 5 questions which I will deal with, which will be touching different concepts which we have studied and which also came in different competitive exams. So let's watch out what are these 5 questions. Now let's start the discussion by dealing with previous year's JEE question. That's the last of the discussion as far as the topic of ray optics is concerned. We'll just have a look at the different questions which we come across in the competitive exams of our interest. So primarily JEE questions are put up. After this, you will get a set of questions which we are discussed, which relates to all the major competitive exams. But in brief, we will discuss few of the questions from the past year JEE papers. The focal length of a thin biconvex lens is 20 cm. When the object is moved a distance of 25 cm in front of it to 50 cm, the magnification changes from m dash to m double dash. The ratio of m dash to m double dash is, I know that the magnification in other form is given to be f by f plus u. So it implies m dash is equals to 20 divided by 20 minus 25 comes out to be minus 4. So my m dash is basically minus 4. M double dash will be equal to correspondingly f divided by f plus u is 20 divided by 20 minus 50. This comes out to be minus 2 by 3. So m dash divided by m double dash is equal to minus 4 divided by minus 2 by 3, which comes out to be 6. So your answer is 6. Now you might ask why the options are not given, because first of all, I want you guys to practice the raw numericals first, and then you can dig into how to play with the options. Because the ray optics, the first and foremost step is to understand the concepts, then work out the concepts, check those concepts, and then the last step will be to develop your objective skills accordingly. So that's why I've deliberately put out the options from these questions. So moving on to the next question. Image of an object is approaching a convex mirror of radius r equals to 20 meter, such that it was observed to have moved from 25 by 3 meters to 50 by 7 meters in 30 seconds. What is the speed of the objects in kilometer per hour? So I know 1 by v plus 1 by u equals 1 by f. So I have already this in place. So I've just put up with this, that is u, I want to find out v first over here. So v, 1 by v equals 1 by f is 1 by 10, given r equals to 20. So 1 by u is basically 3 by 25. If I work this out, I will end up getting v to be minus 50. So this is minus 50. Sorry about this, this will be meters. In the other case, 1 by v equals to 1 by 10 minus 7 by 50. This in turn will give me v to be minus 25 meters. So it means the object moved a distance of 25 meters in 30 seconds. Implies the speed is 25 by 30 meter per second, which in fact is equals to 3 kilometers per hour. So that is the speed of the object. Moving on. A ray of light traveling in the direction 0.5 I cap plus 1.73 j cap is incident on a plane mirror. After reflection, it travels along the direction of 0.5 I cap minus 1.73 j cap. The angle of incidence is, so this is I cap over here, this 1.73 and 1.73 can be taken to be as root 3. So this is your objective skills playing along right now. So make sure that you end up taking root 3 over here. So cos theta, I will explain you what is theta. So theta is, with the help of a diagram, I will explain you what do I mean by this. So it's A dot B divided by AB. So let's say this is my surface, this is the incident ray, and this is the direction in the light reflects. So I want to find out So your theta is basically the angle between the plane and this. So this and this. So given I have the light traveling in the direction of 0.5 this, now it travels along this particular direction. So it's basically the angle between these two, right? This will come up. So I know this line and I know this line. The vectors corresponding to these two lines are given. I just need to find out the angle of incidence. So cos theta, if I run it along, it will come out to be cos theta equals to 1 by 4, 1 minus 3 divided by 1. So it's minus half is equal to cos theta, which implies theta is equal to 120 degrees. So if my theta, if this is 120 degrees, so the whole of it will be 180 degrees. So if it's the whole of it is 180 degrees, it means this plus this, which are kind of equal, will be 60 degrees. It means the angle of incidence is 30 degrees. Moving on to the fourth question. An image of an object formed by a plano-convex lens at a distance of 8 meters behind the lens is real and is 1/3 the size of the object. So the magnification is given and where it's formed, that is also given. The wavelength in the light inside the lens is 2 by 3 times the wavelength in free space. Now from this prospect, I'm getting an information about refractive index. The radius f, or let's say the radius of the curved surface of the lens is. So going by the prior information which I already have, that is 1 minus 1 by 3 is equal to minus 8 by f. Relating the magnification, which implies 1 by f is equal to 1 by 24. My focal length is 1 by 24. Now using the information which I have related to the refractive index and putting it along in the lens maker formula, and I have plano-convex lens, so please keep in mind that I will end up getting 1 by r over here. So 1 by f implies 1 by 24 equals to 3 by 2 minus 1 multiplied by 1 by r, implies r equals to 12 meters. So the radius of curvature, or for the radius of the curved surface, comes out to be 12 meters. Now moving on. A ball is dropped from the height of 20 meters above the surface of the water. The refractive index of the water is given to be 4 by 3. A fish in the lake is looking at the ball directly. At an instant, the ball is 12.8 meters above the surface of the fish. The fish sees the speed of the ball as. So right now the ball is actually falling at a particular height, and I want to find out the speed at which it's will be, or the speed of the ball with respect to fish. What will be the speed with respect to the fish? So I know that the apparent height is equal to the height by mu r divided by mu I. So the velocity with which I am appearing to be moving will be obviously the velocity of the object, mu I by mu r. So right now it's 20 meter. The object started from 20 meter. It ended up being at a height of 12.8 meters. So it implies the distance moved is 7.2 meters. So corresponding to that, I can find out what is the actual speed of the object. So our actual speed of the object will come out to be 2 into g into 7.2 meters. This is the speed of the object. If I put along the value of this, so the apparent speed comes out to be, if you evaluate it g, it comes out to be 12 meter per second. 2 into 10, 20 into 7.2 comes out to be 144 or 12 meter per second. So the apparent velocity will come out to be 12 into 4 by 3, that is 16 meter per second. That's the speed with which the fish is seeing the ball to be dropping.
While going through the lecture, if you face any doubt, you can post your doubt for free at askIITians.com. In order to do so, you first need to navigate to the askIITians.com. Then, while going to that link, you can use discussion board link, which is over here. Clicking on this particular discussion board link, it will take you to a page where under the head of Ask the Experts, you can post your doubt under various categories. And the team of Ask IITians Expert will get back to you between 24 to 48 hours.
So I hope you guys have understood all the concepts which were delivered to you, and also you have understood the problems associated with each concept. So let me just jot down the different topics which we have discussed in the chapter of ray optics. We started off with the introduction about light. Light is a wave or light is a matter. Then we moved on to one of the most important phenomena associated with light, that is reflection. Then we moved on to the second most important, that is refraction, and the different instruments involving refraction, that is lens, prism, and different spherical surfaces as well. Then we learned about the penultimate phenomena associated with light in the chapter of ray optics, that is dispersion, and then also its natural phenomena which we see in our day-to-day life. Then in the concluding part, we learned, or actually we put out all the concepts which we have learned in that whole chapter in designing and coming up with new optical instruments such as microscopes and telescopes. And finally, we just had a dry run of 5 problems which came in the last year competitive exams. So if you have more doubts, you can log on to askIITians.com, and for more videos in physics, chemistry, maths and biology, again you can log on to askIITians.com. So that's all from me in this side. Bye bye, take care.